One important condition when you're using partial fraction decomposition is that the degree of the numerator needs to be less than the degree of the denominator. So if you're faced with an integral that looks like this, you first need to do division before we actually evaluate the integral. So let's just note that the degree of the numerator is bigger than the degree of the denominator. So if it's bigger than or even equal to, even if it's equal to, that means we need to divide first. In fact, let's just say bigger than or equal to. Alright, so we'll do division. It's probably been a while since some of you have done long division with polynomials. So I'll kind of go slowly. I'll write this as 3x to the fourth plus 0x cubed plus 0x squared plus 0x plus 1. And we're going to divide x squared minus 1 into that. So I would say, how many times does x squared go into 3x to the fourth? About 3x squared times. So 3x squared times x squared, you multiply back, gives you 3x to the fourth minus 3x squared and then you subtract, and just be careful with subtracting here because 3x to the fourth minus 3x to the fourth is 0. 0x squared minus a negative 3x squared is a positive 3x squared. And then you bring down the only thing that you can bring down, which is this plus 1. X squared times what gives you 3x squared? 3. And then you multiply back. And then you subtract. So that's 0, and this is 1 minus negative 3, which is a 4. So it's important to be able to interpret this. What this means is, so we did this division, and we ended up getting, so just like when you do 4/3, it goes in once with a remainder of 1, you can say, oh, that's 1 plus 1/3. So in the same way here, we can write this as 3x squared plus 3 plus that remainder, which is a 4, plus 4 over x squared minus 1. All right, and so notice now that this integral just kind of broke into two pieces. So we're going to write it as two integrals. And this left one's done. I mean, we'll do this later. That's easy. It's this right one that we're going to actually have to continue with. All right, so we got to focus our attention now on this. But so that's the one on the left is we can do that at the end. It's easy. Here, the one on the right, we're going to need to use partial fraction decomposition again because you've got a polynomial at the bottom whose degree is bigger than the one at the top. So that'll factor into something over x plus 1 plus something over x minus 1, and multiplying the top and the bottom by x minus 1, and over here x plus 1 will give us this relationship. So 4 equals a times x minus 1 times plus b times x plus 1. All right, and then use intelligent values. So when x equals 1, we get 4 equals 2b, which means that b is equal to 2. And when x equals negative 1, we get 4 equals negative 2a. So a is equal to negative 2. It's important you keep track of your a's and your b's and where they go, because you need the a to go, the a is, as we wrote it, needs to go over the x plus 1. So that means that the integral 4 over x squared minus 1 dx is equal to a, which is negative 2 over x plus 1 plus 2 over x minus 1. And so this equals negative 2, the natural log of absolute value of x plus 1, plus 2, natural log of the absolute value of x minus 1, plus c. And so we're almost done. The only thing to do is to remember that we had a second arm over here, right? So the antiderivative of that guy is x cubed plus 3x. And so our final answer is x cubed plus, so final answer would be that integral is x cubed plus 3x minus 2 ln of the absolute value of x plus 1 plus 2 ln the absolute value of x minus 1 plus c. All right, so the main theme of this video was that you needed to divide first, and then you had to deal with whatever you were looking at afterwards, which again required in this case partial fractions.